Welcome back to the deep dive. Okay, I want you to close your eyes for a second. Seriously, just humor me.
All right.
Imagine you wake up tomorrow morning, you're groggy, maybe a little hungover, and you realize you are not in your bed. You aren't even in your house. You're on a spaceship. And not just any spaceship. I mean, this thing is massive. It is incredibly complex, and it is hurtling through the black void of space at about 67,000 miles per hour.
That is a very specific speed.
I looked it up. It's wild. We are moving fast. And this ship, it has everything you could ever want. It's got a self-regulating life support system. It recycles its own water, purifies its own air.
It creates its own food.
It creates its own food. It is a total marvel of engineering. Yeah. But here's the catch, and this is the part that should, make you sweat a little.
Uh-oh.
There's no flight crew. There's no captain on the bridge, no autopilot. It is just us, you, me, the listener, and 8 billion other kind of confused passengers. And up until very recently, we have been acting like we not only lost the instruction manual, we're actively ripping pages out of it to start fires because, I don't know, we like the pretty colors.
That is a terrifying, but unfortunately, a statistically accurate analogy. We're treating the vessel like a rental car that we bought the extra insurance for.
Yeah.
So we just don't care if we scratch it. Except, there's no rental agency to return it to. This is it.
This is it. We are pushing buttons. We are pulling levers. We are eating all the rations in the cargo hold. And we're just hoping that all those red flashing lights on the dashboard are, I don't know, just decorative.
That check engine light, it's probably just a sensor error.
It's probably fine. But today, we're actually going to try to find that instruction manual. We are doing a deep dive into a text that is, well, it's essentially the survival guide for the human species.
It really is.
It's called Environmental Science, 13th edition, and it's written by G. Tyler Miller and Scott E. Spoolman.
Yeah.
And look, I know what you're thinking. A textbook.
Right.
Really. I came here for a deep dive, not homework. But trust me, this is not dry reading. This is the blueprint for how the world actually works.
And honestly, calling it a textbook almost does it a disservice. It's really more of an investigation. Miller and Spoolman aren't just, throwing facts at us to memorize for a quiz. They're presenting a very specific evidence-based argument. And that argument is that we are a species that is currently in the process of systematically dismantling our own life support system. That's the bad news, and they do not sugarcoat it.
They really, really don't. Some of the charts in here are, well, they're alarming.
But the good news, and they are very insistent that there is good news, is that we aren't flying blind because we can't see. We're flying blind because we won't look.
Oof.
We actually understand how the system works. We know the physics. We know the biology. The question isn't whether we can save the ship. It's whether we will choose to read the manual before, the oxygen runs out.
Exactly. And that's the mission for this deep dive. We want to move past the headlines. We all see the doom and gloom news, the melting ice, the plastic in the ocean, the extinctions. It is so easy to just shut down.
It's apocalypse fatigue. It's a real thing.
It is. But today we're going to look under the hood. We want to understand the actual mechanics of the planet. To do that, we have to unpack one word that gets thrown around a lot. A word that has almost lost its meaning because it's on every corporate pamphlet, every coffee cup.
Every H&M tag.
Yeah.
Sustainability.
It has become such a buzzword, hasn't it? It's right up there with synergy and disruptive. But in the context of environmental science, sustainability is not a marketing term. It has a rigid biological definition.
Okay.
It is not just being green or remembering to recycle your soda can. Sustainability is the ability of the Earth's various natural systems, and by extension, human cultural systems and economies, to survive and adapt to changing environmental conditions indefinitely.
Indefinitely. That is a long time. That is not until the next fiscal quarter.
That's not until my grandkids are grown. That is...
Forever. Effectively, yes, forever. And to understand why that matters, we have to zoom out. I mean, way out. Look at the timeline.
Okay.
Life on Earth has sustained itself for at least 3.5 billion years. Just think about that track record for a second.
It's staggering.
The planet has been hit by city-sized meteors. It has frozen over in ice ages where glaciers reached the tropics. It's heated up until the oceans were like hot baths. Continents have smashed together and ripped apart. And yet, through all of that, the system survived. It adapted.
Life found a way.
Life found a way. Humans, we've been here for maybe 200,000 years. If the history of the Earth were a 24-hour day, we showed up in the last few seconds before midnight.
Wow. So the question isn't really, can the Earth survive? The Earth is tough. The Earth is a scraping, clawing survivor.
Absolutely.
The question is, can we survive on it?
Precisely. The Earth will be fine. It might take a few million years to shake off a fever, but it'll recover. We, however, we are fragile. We need a specific temperature, a specific mix of gases in the air, specific calories. And this brings us to a distinction the authors make right at the very start, which I think frames this entire discussion.
Okay, what's that?
They ask a really provocative question. Are humans smart or are we wise?
Okay, let's unpack this. Because I like to think I'm pretty smart. I mean, collectively.
Sure.
We split the atom. We built the internet.
Yeah.
We put a rover on Mars that can tweet. We are clever little monkeys.
We are incredibly smart. We have these complex brains. We've mastered technology. We can manipulate our environment better than any species in history. We can flatten a mountain to get at the coal inside.
Right.
We can dam a massive river to make electricity. That is smart. But wisdom is different.
How so?
Wisdom is looking at that 3.5 billion year track record of nature and saying, maybe we should copy that. Wisdom is recognizing that if you degrade your own home, you might be clever, but you certainly aren't wise.
That hits hard. It's the difference between knowing how to build a fire, which is smart, and knowing better than to build it on the floor of your living room.
Which is wise.
Yeah.
That is actually a perfect analogy. We are currently burning the floorboards to keep warm, and we're congratulating ourselves on how high the flames are, while the actual foundation of the house is weakening.
Okay, but wait, let me push back on that for a second.
Please.
Because burning the floorboards, burning fossil fuels,
Yeah.
using resources, that's what built the modern world. It gave us hospitals. It gave us this microphone. It gave us the ability to not die of an infected tooth at age 30.
A very real thing.
It feels a little harsh to call that unwise when it kept us alive and comfortable.
And that's a valid pushback. The authors aren't saying technology is bad. They are not saying we should go back to living in caves. But what they are saying is that a system that relies on burning the house down to stay warm has an expiration date. It was smart for a short-term burst of progress. But if we want to stick around for the long haul, indefinitely, we have to transition from that smart survival to wise living.
Okay, I see the distinction.
Yeah.
So to understand how to be wise, the text introduces this financial metaphor that I found really, really helpful. Because let's be honest, most of us understand money better than we understand ecology.
Sad but true.
It's the bank account analogy.
Right. So Miller and Spoolman use terms from economics. Capital and income. In a financial sense, capital is your wealth, your savings, your investments, the pile of money you have sitting in the vault.
Okay,
Income is the interest or the earnings that flow from that capital.
got it. Okay, so let's play the lottery. Let's say I win $1 million.
Nice.
That is my capital. I am rich. I am buying a monocle.
Congratulations on the monocle. Now you have two choices. Scenario A. You invest that $1 million. Let's say you get a nice, steady 10% return.
Okay, so that's $100,000 a year.
That's $100,000 a year in interest. That is your income. If you live on just that $100,000, what happens to your $1 million capital?
Nothing. It just sits there. I can live on the $100,000 forever, indefinitely. I'm not buying private islands, but I'm comfortable.
Exactly. That is a sustainable lifestyle. You are living on the income without touching the capital. Now, scenario B.
Uh-oh.
You get that $1 million, but you decide you want to live like a rock star. You want a yacht. You want a fleet of Ferraris. You spend $200,000 a year.
Well, the math there is pretty simple, isn't it? I am bankrupt in, 6 or 7 years?
But here's the thing. For those first 5 years, you looked incredibly successful. You had the best parties. You had the nicest stuff.
Oh, yeah.
If someone looked at your life in year 3, they would say, wow, look at how well he is doing.
But it's an illusion. It's just a countdown to zero.
Exactly. It's an unsustainable lifestyle. Once the capital is gone, the income stops. The party is over. Now let's apply this to the Earth.
Okay. So in this analogy, the Earth has basically given us a trust fund, a giant one.
Yes. We call it natural capital. This includes all the resources we use, the air, water, soil, wildlife, minerals, all of it.
And the natural income would be?
That is the renewable part. The fresh air that's constantly purified by plants, the fresh water replenished by rain, the fertile soil that regenerates, the fish stocks that reproduce. A sustainable society lives on that natural income.
Okay.
They harvest fish, but only as fast as the fish can reproduce. They cut trees, but only as fast as the forest can grow back.
But the source material argues that's not what we're doing.
No. We are burning through the capital. We are depleting the savings account. We're eroding soil faster than it forms. We're taking fish from the ocean faster than they can breed. We are treating the Earth like scenario B.
The rock star scenario.
We're spending the $1 million and just assuming the check will never bounce. We look rich right now because we're drawing down our savings, but what we're really doing is stealing from the future to pay for the present.
And here's where it gets really interesting and honestly a little abstract, so I want to drill down here.
Let's do it.
The book breaks down natural capital into 2 different buckets, and I think most people only ever think about one of them.
This is such a crucial distinction.
There are natural resources and natural services.
Yes. So natural resources are the stuff, the physical materials, oil, copper, water, trees. We can see them, we can weigh them, we can put a price tag on them. If I chop down a tree, I can sell the lumber. That's a resource.
Easy enough.
Yeah.
But natural services, these are the things we completely forget are even happening. These are the processes. And the text lists a bunch of them. Air purification, climate control, UV protection from the ozone layer, pest control, soil renewal.
Let's just talk about soil renewal for a second. It sounds boring. It sounds like dirt.
It does. I mean, it's dirt. It's everywhere. Why is that a service?
Because soil isn't just crushed rock. Topsoil is a living ecosystem. It is full of bacteria, fungi, worms, and insects that break down organic matter like dead leaves and turn it into nutrients that plants can eat. Okay. It takes nature centuries, sometimes thousands of years, to build 1 single inch of topsoil.
1 inch? Wow. Okay, so it's slow.
It's not just slow, it's absolutely essential. Without that topsoil, we don't have food, period. End of story. Now, imagine if we had to replace that service with our own technology.
Right.
Imagine if we had to build a machine to take dead leaves and rocks and turn them into nutrient-rich soil for every farm on Earth.
The cost would be, I mean, you can't even calculate it. It'd be astronomical.
It would be impossible. We couldn't do it. Nature does it for free. That is a natural service.
Right.
Or take pest control. Birds and spiders eat the bugs that eat our crops.
Sure.
If we kill the birds and spiders with pesticides, suddenly we have to do the pest control ourselves with more and more chemicals. We are replacing a free, perfect, self-regulating natural service with an expensive, imperfect human one.
That's the instruction manual part we're missing. We look at a forest and we just see lumber, a resource. We don't see flood control or air purification, the services. And because those services are free, we value them at 0.
And in economics, when you value something at 0, you tend to waste it. We treat the atmosphere like a free sewer because we don't get a bill for air disposal services at the end of the month.
But we are paying for it.
Oh, we are paying for it.
In other ways.
Okay, so if nature has been running this sustainable bank account for 3.5 billion years, surely there are rules. There's got to be a system.
There is.
And the text identifies 3 specific principles of sustainability. These are like the 3 keys to the kingdom. If we understand these, we understand how the ship works.
And these 3 principles are derived directly from observing how nature works. They're not, just some nice ideas. They're laws. If we want to be wise and not just smart, these are the laws we need to follow.
All right. Principle number 1, reliance on solar energy.
This seems obvious, right? The sun is hot. We all know that.
Yeah.
But the scale of it is just staggering. The sun is the engine of everything.
Everything. It warms the planet to a livable temperature. I mean, without the natural greenhouse effect, which is a good thing. We just ramped it up too high. The Earth would just be a frozen rock.
But it's not just warmth. It's food.
It is all of our food.
Yeah.
Photosynthesis. The sun hits a leaf. The leaf takes carbon dioxide from the air and water from the ground and turns it into sugar. That sugar is the battery that powers the entire food web on the planet.
The whole thing.
Sun hits leaf, leaf makes food, a bug eats the leaf, a bird eats the bug, maybe we eat the bird, or we just eat the leaf. It is all processed sunshine. When you eat a salad, you are eating sunlight.
When you eat a steak.
You are eating sunlight that walked around and mooed for a while.
I love that. But let's go deeper here, because the text mentions that even things like wind and water power are fundamentally solar. That kind of bent my brain a little.
Stop and think about the physics of that for a second, though. We look at a windmill and we think wind energy. But what is wind?
Air move.
Air moving from a high-pressure area to a low-pressure area. And why are there pressure differences? Because the sun heats the equator more than it heats the poles. The entire atmosphere is just a giant heat engine trying to equalize that temperature difference. So a wind turbine is really just a kind of solar panel that works at night.
And hydroelectric power. Same thing.
Same thing. The sun evaporates water from the oceans. That water vapor rises, forms clouds, moves over land, and rains down into rivers. That flowing water turns the turbine.
So no sun, no evaporation, no rain, no river.
It's all solar.
So the instruction manual says, power the ship with a giant nuclear reactor in the sky.
Right.
Meanwhile, we're down here digging up fossilized plants, which are just ancient stored sunlight, I guess, and burning them.
Which brings us to why that's a problem. But before we get there, we need the second principle.
Okay, what is it?
Biodiversity.
Now, when people hear biodiversity, I think they just imagine a zoo or, the Amazon rainforest with a bunch of colorful parrots.
Sure, lots of animals.
But the text defines it as much more than that.
Right. It's the variety of organisms, yes, but it's also the variety of systems they live in. Deserts, oceans, forests, and crucially, the variety of genetics within each species. The text calls biodiversity an insurance policy.
An insurance policy?
Yeah.
I like that. Unpack that for me. Because usually insurance is something I pay for, and I hate it until I crash my car.
Well, imagine you're a farmer and you plant only one type of potato, the lumper potato. This actually happened in Ireland in the 1800s.
I think I know where this is going.
The entire population relied on this one genetic variety. Then a fungus came along, a potato blight, and it happened to love that specific potato. It wiped out the entire crop in what felt like overnight.
And the result was the Great Famine.
Millions died or fled because they had no genetic diversity, no backup plan. Now imagine a wild meadow. You have 50 different types of grasses and tubers in there. A bug comes along that eats one specific type of grass. Fine. That one type dies back. But the other 49 fill in the gap. The system holds. Biodiversity provides resilience. It prevents life from being wiped out by a single catastrophe.
The book has this incredible visual on the cover that ties right into this. It's a green sea turtle.
It's a perfect ambassador for this principle.
And I want to describe this for you if you haven't seen it, because it's really stunning.
Please do.
You're underwater. The light is filtering down in these shafts of blue. And you see this creature. It's massive, up to 4 feet wide, maybe 300 to 400 pounds. It looks ancient.
They are.
It has this leathery, wrinkled skin and a shell that looks like a mosaic of green and brown tiles. It's grazing on seagrass like a cow in a pasture. This animal looks like it knows secrets about the universe.
It literally walked, or swam, I guess, with the dinosaurs. The ancestors of this turtle were in the oceans 100 million years ago. They survived the asteroid that wiped out the T-Rex. They survived ice ages. They survived the ocean's heating and cooling. They are the ultimate survivors.
And yet today, they're endangered.
Because of us. And the threats are numerous, which really highlights how we disrupt biodiversity. We hunt them for meat and eggs. They get caught and drowned in our plastic fishing nets. But there's one specific threat that just breaks my heart, and it shows how disconnected we are. It's about their babies.
The hatchlings.
Yes. The mother turtle hauls that 300-pound body onto the beach at night, the very same beach she was born on. She digs a pit, lays about 100 eggs, covers them up, and leaves. 2 months later, the babies hatch. They're tiny, soft, completely vulnerable.
And they have to get to the ocean.
They have to run a gauntlet to get to the ocean. And they do this at night, right?
Right.
And for millions of years, they had a simple instruction baked into their DNA. Go toward the light. Because at night, on a natural beach, the brightest thing in the sky is the reflection of the moon and stars on the water.
Oh no, but now
we've built hotels and condos and parking lots right on the beach. We have street lamps. We have neon signs for bars.
So the babies hatch, they pop their heads out of the sand, and they see a bright street light in the parking lot.
And they think it's the moon. They turn away from the ocean and they crawl toward the road. They get run over by cars, eaten by cats, or they just die of dehydration in the gutter.
That's just tragic. Here's a species that survived an asteroid, but it can't survive a street lamp.
And that is the lesson. Biodiversity is resilient against natural shocks, but it is incredibly fragile against the specific types of rapid industrial shocks that humans introduce.
So when we lose biodiversity,
we are canceling our insurance policy. We are making the entire ecosystem simpler and therefore weaker. It's like we're removing the rivets from the airplane wing while we're flying it.
Okay, that image is going to stick with me. So principle 1, use the sun. Principle 2, keep the insurance policy, which is biodiversity. That brings us to principle 3, chemical cycling.
Or, as I like to call it, nature has no trash.
This is the one that really blows my mind when I look at how we operate. Because we love trash. We make mountains of it.
In the natural world, there is no such thing as waste. It just doesn't exist. Every output from one organism is an input for another.
Okay, give me an example.
A leaf falls from a tree. Bacteria and fungi eat it, and they turn it back into soil nutrients. An animal poops, that's fertilizer for the grass. An animal dies. Scavengers and decomposers break it down into its base chemicals. Carbon, nitrogen, phosphorus.
And those go back into the soil.
Those chemicals go back into the soil, the plants suck them up through their roots, and the whole cycle starts all over again. It is a completely closed loop.
It has to be, doesn't it?
It has to be. The Earth is a closed system for matter. We don't get shipments of nitrogen from Mars. We have to reuse what we have. If nature didn't recycle, life would have used up all the available nutrients billions of years ago and just stopped.
And contrast that with us. I'm looking at my plastic water bottle right here.
Okay, that bottle is made of oil. You drink the water in, 5 minutes? Then you throw the bottle away, it goes to a landfill. Does it turn it into soil?
No. It just sits there for 500 years.
Exactly. It breaks the cycle. We are taking resources from the Earth, turning them into products, and then turning them into waste that cannot be reabsorbed by the system. We are linear thinkers in a cyclical world.
It's like we're clogging the gears of the machine with our trash.
That's a great way to put it. We're on the spaceship, and instead of recycling our water, we're just drinking it once and storing the dirty water in the cargo hold. Eventually, you run out of water and you run out of space.
And that is exactly what's happening. And it's not just physical trash, right? It's invisible things, too.
Yes. We are taking carbon that was stored safely in the ground as fossil fuels, and we are dumping it into the atmosphere way faster than the natural cycle can remove it. We're taking nitrogen from the air to make fertilizer and letting it wash into the rivers, which overloads the water cycle. We are jamming all the gears.
So we have the manual now. Sun, biodiversity, cycling. It sounds so simple when you lay it out.
It is elegant in its simplicity.
But clearly, we've not been reading it. Let's talk about the impact, the bad news, if you will, because the book makes it very clear that our refusal to follow these rules is having real-world consequences right now.
We have to face the scale of human influence. We dominate the Earth's life support system. Some estimates say we've modified something like 80% of the Earth's land surface.
80%.
We aren't just living on the planet, we are actively terraforming it. And the text posits that we are acting as the unwise species because we're depleting that natural capital we talked about earlier.
The book uses some really striking visuals to show this degradation. And I want to describe a few because they really paint the picture. There's one photo of an oasis in the Sahel region of West Africa.
Yes, the Sahel. This is a semi-arid region just south of the Sahara Desert. And in the photo, you see what looks like a battle between life and sand. And the sand is winning.
It's so stark. You see these palm trees, which look like they should be lush and green, but they're surrounded by these encroaching sand dunes. The sand is literally burying the trunks of the trees. It looks like the desert is eating the village.
And that's desertification. It's caused by a combination of drought, which is natural, but it's made much, much worse by human activity like overgrazing and unsustainable farming.
We're pushing the land too hard.
We strip the vegetation that holds the soil in place. Once those roots are gone, the wind just picks up the topsoil and blows it away, and the desert simply walks in. That is a permanent loss of natural capital. That land is no longer productive. It's gone.
Then there is a photo that feels a lot closer to home for many of us. It's a street scene in Turin, Italy. And it looks like a normal city, street traffic, cars, buildings. But the children walking to school are wearing face masks.
And this book was published before the COVID-19 pandemic. This wasn't about a virus. This was purely for air pollution. It illustrates that this isn't just a problem for nature out there in the wild. It is a problem for us in our cities. We are degrading the very air we need to breathe. We're poisoning our own habitat.
And the third one. This one is just visceral. It's a photo from France. A pipe is discharging water into a stream. But the water isn't brown or murky. It is bright, blood red.
Point source pollution, likely from a dye factory or some other industrial plant. It looks like something out of a horror movie.
It really does.
But it represents how we treat the water cycle. We use water to carry away our waste, assuming away is some magical place where things just disappear. But in a closed system like Earth, there is no away.
No away.
That red water goes into a river, which goes into the ocean, which evaporates into rain, or gets absorbed by fish that we might end up eating. We are essentially spitting in our own soup.
So why are we doing this? I mean, if we are so smart, if we can build the internet and solar towers, why are we sawing off the branch we're sitting on? The text identifies 4 root causes, 4 big reasons why we have these environmental problems.
Right. And they're all interconnected. You can't really solve one without looking at the others. The first one is just simply population growth.
More people need more resources. That's simple math.
It's exponential math. We've moved from 1 billion people in 1800 to nearly 8 billion today. Even if every single person used very little, that is a huge strain on the system.
And it's still growing.
We are adding 80 million people a year. That's like adding a new Germany to the planet every single year. All those people need food and water and space.
Okay, that's one. The second cause is poverty. Now, this is interesting because I think a lot of the time we blame industrialization and big corporations. But the text argues poverty is a major driver of environmental degradation.
It is a desperate kind of degradation. It's pure survival mode. Imagine you're a father in a poor village. You know that cutting down the trees on the hillside will probably cause mudslides and ruin the soil in 10 years.
Okay.
But you need to cook food tonight to feed your children, and wood is the only fuel you have. What do?
I cut down the tree. I don't care about 10 years from now. I care about dinner tonight.
Exactly. Poverty forces people to deplete their own natural capital just to survive the day. They don't have the luxury of thinking about sustainability.
But then you flip the coin. And cause number 3 is affluence, or more specifically, wasteful resource use. This is us.
This is the lottery winner scenario B. This is the rock star. In wealthy nations, we buy far more than we need. We use precious resources to make throwaway items.
Like my water bottle.
We buy a phone, we use it for 2 years, and then we throw it away because the battery is slightly worse. We buy clothes we wear once. The text points out that one American consumes about 30 times as much as the average citizen of India.
30 times. That's a staggering number.
It is. So in terms of environmental impact, one American baby is equivalent to 30 babies in a developing nation. Affluence drives massive consumption, which fuels the pollution in the first place.
And the fourth cause. Okay, this is the one that I think explains the most about our economy. It's the one that makes me look at my receipts differently. Excluding environmental costs from market prices.
This is the hidden cost problem. Economists call these negative externalities.
Let's break this down with an example. Let's say I go to a fast food drive-thru and I buy a hamburger for $5.
Okay. That $5 pays for the meat, the bun, the labor of the cook, the electricity for the building, the shipping, and a little profit for the franchise owner.
Sounds fair. The market has spoken. The burger is worth $5.
But is it? Let's think about the life cycle of that beef. To grow the corn to feed the cow, the farmer used massive amounts of fertilizer. Some of that fertilizer washed into the river and created a dead zone in the Gulf of Mexico where fish can't live. That hurts the fishing industry.
Okay, but who pays for that?
Not you, not at the drive-thru window. The cow released methane, which is a potent greenhouse gas, and that contributes to climate change, which causes stronger hurricanes. Who pays for the hurricane damage? The taxpayers do. The truck that delivered the meat spewed diesel fumes that gave a kid in the city asthma. Who pays for that kid's inhaler?
The kid's parents.
Exactly. So the real cost of that hamburger isn't $5. It's maybe $15 or $20. But the extra cost is being paid by the fisherman, the taxpayer, and the asthmatic kid.
We privatize the profits and we socialize the costs.
You got it. The market price is artificially low because it ignores the environmental reality. And because the price is so low, what do?
We buy more burgers.
We overconsume. It completely distorts the economy. It makes doing the wrong thing profitable and doing the right thing expensive. If that burger costs $20 to reflect its true damage, you might eat fewer burgers. You might choose a bean burrito instead. The market would correct itself. But right now, the market is lying to us.
That is infuriating. It feels like we're being scammed.
We are scamming ourselves at the end of the day.
Okay, so we have the manual. We know we're breaking the rules, and we know why we're breaking them. Now we need a toolkit to fix it. And the text makes a very, very important distinction here between environmental science and environmentalism.
Yes.
Because I think people conflate them all the time. They hear environmental science, and they think hippies chaining themselves to trees.
They do, and it is absolutely crucial to separate them. Environmental science is what we are discussing today. It is a science. It's interdisciplinary biology, chemistry, geology, social sciences. It is supposed to be objective.
It's about data.
It's a study of connections. It's about data, hypotheses, and peer review. It asks, what happens if we add 10 tons of carbon to the air? And it measures the result.
And environmentalism.
Environmentalism is a social movement. It is dedicated to protecting the earth. It is political. It is ethical. It is passionate. It asks, is it right to destroy the forest? That is a value judgment. not a scientific one.
So environmental science is the diagnosis, and environmentalism is the treatment plan.
Or maybe environmentalism is the will to undergo the treatment. You need the science to know what medicine to take, but you need the movement to convince society to actually swallow the pill.
We need both, but we can't confuse them. We need the objective tools to find the solutions.
And that requires critical thinking. The authors actually include a guide in the text on how to detect baloney.
I love that title, a baloney detection kit. Because, let's be honest, there is so much baloney out there, especially on the internet.
An endless, all-you-can-eat buffet of baloney.
So let's role play this. Let's test the kit out. I'm scrolling through social media and I see a headline. New study shows volcanoes emit more CO2 in one day than humans do in a year. Climate change is a natural hoax.
Okay.
It has a picture of a volcano exploding. It looks scary. It has 50,000 likes. How do I use the kit?
Okay, let's put on our lab coats. Rule number 1 from the kit, question the source. Who posted this? Is it a peer-reviewed scientific journal like Nature or Science, or is it freedomeaglepatriotnews.com?
It's a meme account, but they do cite a Dr. Smith.
Okay. Who is Dr. Smith? Is he a climatologist? Or is he, say, a dentist? And who funds his work? The kit tells us to look for bias in funding sources. If Dr. Smith works for a fossil fuel lobby group, we should probably be skeptical.
Okay, that makes sense. Rule number 2, check the evidence.
The claim is volcanoes emit more CO2. We can check that. We can look at the consensus science. The U.S. Geological Survey, who, studies volcanoes for a living, has data on this. And it turns out human activities emit about 60 to 100 times more carbon dioxide annually than all the volcanoes on Earth combined.
So the headline is total baloney.
Complete baloney. But it feels true because volcanoes are big and scary and dramatic. That's why we need the kit. We have to separate truthiness, what feels true, from what is actually factually true.
They also talk about this great metaphor for studying and critical thinking that I really liked. Do not eat dessert first.
Ah, yes. The dessert is the opinion. It's the fun part. It's jumping to the conclusion. It's stating, I believe solar power is the best. Or, I think nuclear power is too dangerous. It tastes good to have an opinion.
But the main course.
The main course is the vegetables, the protein. It's the hard work. It's reading the data, understanding the chemistry of a photovoltaic cell, analyzing the half-life of nuclear waste. You have to eat your vegetables, do the actual research, before you earn the right to the dessert of having an informed opinion.
I feel like our entire culture is just gorging on dessert right now. We are diabetic with opinions.
And we are malnourished on facts.
Okay, one more tool in the toolkit before we get to the solutions. The brain. The text discusses the left brain versus the right brain.
It suggests we need a synthesis of both. The left brain is the logic, the analysis, the critical thinking we just talked about. It breaks problems down into their component parts.
It's the part that looks at the $5 burger and calculates the external costs.
Yeah, in the right brain.
The right brain is creative, it's visual, it's the synthesizer, it imagines what doesn't exist yet, it sees connections.
So dealing with environmental problems isn't just a job for the scientists in lab coats.
No. If we only use the left brain, we just get a very precise and accurate measurement of how doomed we are, and we get depressed.
Right.
We need the right brain, the artists, the visionaries, the inventors, to dream up the solutions. We need someone to look at a slimy pond of algae and say, you know what, I bet I can make jet fuel out of that.
We need the creativity to imagine a sustainable future that is actually fun and appealing to live in.
Which brings us nicely to section 5, the solutions. Because the authors promise this is not all gloom and doom. They really emphasize that we actually have the technology and the know-how to fix this.
Yeah.
We're not waiting for a miracle. We just need to deploy what we already have.
They do. And it starts with a concept that I think is very mature and very important, the concept of trade-offs.
Meaning there's no magic bullet, there's no perfect energy source.
Correct. Every single solution has a downside. Wind turbines kill some birds, though far fewer than house cats or office building windows do.
Right.
Solar panels require mining for rare metals. We have to be mature enough to weigh the pros and cons of our options.
The example they give is forestry. We want to save the old-growth forests, the ones with the high biodiversity, the ancient trees, the spotted owls.
What magical places.
But we also need wood for houses and paper. We can't just stop using wood entirely.
So the trade-off is the tree farm. You see these sometimes when you're driving down the highway, just these perfect rows and rows of identical pine trees. It looks like a cornfield made of wood. It's a monoculture.
It's not a real forest. It has very low biodiversity. If a specific bug comes along, it could kill the whole farm.
Exactly. It's an ugly solution in some ways. It violates the biodiversity principle locally. But if growing that ugly tree farm allows us to get the wood we need so that we can leave the ancient, magical forest down the road completely untouched,
And then it's a good trade-off.
it's a good trade-off. We sacrifice the biodiversity of the farm area to save the irreplaceable biodiversity of the wilderness. That is the kind of pragmatic thinking we need.
It's not about being purists. It's about being effective. Okay, now let's look at some of the cool tech. The text has some great visuals of what a sustainable future could actually look like. One that caught my eye was the straw bale house.
The one in Crested Butte, Colorado.
Yeah, I mean, it sounds like the Three Little Pigs, right? I'll huff and I'll puff and I'll blow your house down.
Sure.
But this is high-tech engineering, using very low-tech materials.
Straw is an agricultural waste product. Usually farmers just burn it, but it is an incredible insulator. By building the walls out of these tightly packed straw bales and plastering over them, you create a house with these thick, super insulated walls.
And Colorado gets cold.
It gets freezing. But this house holds heat so well that it needs barely any fossil fuel to stay warm. It might stay warm just from the body heat of the people inside and the heat from the lights. It is using a waste product to save energy that is smart and wise.
Then there are the solar towers. There is an image of a plant in Spain. And this does not look like a normal solar farm with flat panels. This looks like the Eye of Sauron.
It really does. It is intense. What you're seeing is a field of hundreds of mirrors. They're called heliostats, and they're all controlled by a computer to track the sun perfectly. They reflect all that light to a single point on top of a central tower.
It must get incredibly hot up there at that focal point.
Thousands of degrees. It heats a fluid, often molten salt, which then boils water to create steam to turn a turbine, just like a normal power plant. But here is the genius part. That molten salt holds its heat like a really good thermos.
So when the sun goes down.
The salt is still incredibly hot. It can keep boiling water and making electricity for 6, 8, maybe 10 hours after sunset.
It solves the biggest problem of solar power.
What happens at night?
Exactly. This is baseload solar. It's massive industrial scale sustainability.
And then on the complete flip side of the scale, we have flexible solar cells.
Nanotechnology. This is cool. Imagine solar cells that aren't rigid glass plates but are thin, printable sheets. You could roll them up, could sew them into a backpack to charge your phone while you hike. You could mold them onto the roof of an electric car to extend its range.
This goes right back to Principle 1, reliance on solar energy. We are finally building the technology to actually do it on a massive scale and on a personal scale. We can paint the world with solar.
We are. The tools are there. The spaceship has the upgrades ready to install.
But tools don't use themselves. This brings us to the final sub-theme of the book, and you could argue it's the most important one. Individuals matter.
It is so easy to feel small when you're talking about global climate change. You look at that solar tower and you think, well, I can't build that in my backyard.
Right. What can I do?
You look at the melting ice caps and think, I can't stop that. But the text highlights that almost all significant change starts with individuals.
They mentioned Chattanooga, Tennessee.
A great success story. In the 1960s, Chattanooga was one of the dirtiest cities in America. It's in a valley, so the pollution just sat there.
It was an industrial bowl. The air was so bad that men would take 2 shirts to work because the first one would be gray with soot by noon. People drove with their headlights on at lunchtime because the smog blocked out the sun.
That sounds completely dystopian.
It was. But the citizens got fed up. It wasn't a federal mandate that came down from on high. It was local people, individuals, gathering in town halls, shouting, arguing, brainstorming. They decided they wanted a better place to live.
So what did they do?
They set goals. They cleaned up the industrial smoke. They completely revitalized the riverfront. They introduced electric buses way before it was cool. And now, if you go to Chattanooga, it's beautiful, it's green, it's vibrant. It is consistently ranked as one of the most livable cities in the country.
And that didn't happen by accident.
It happened because individuals decided to act.
And then there's the story of Wangari Maathai. I love her story.
The Greenbelt movement in Africa. She was a Kenyan woman, the first African woman to win the Nobel Peace Prize. And she looked at her country and she saw the bad news we talked about.
The degradation of capital.
Exactly. The soil was eroding, the streams were drying up, and the women had to walk for miles just to find firewood. It was a breakdown of natural services.
So what did she do?
She didn't wait for the government. She didn't wait for a giant solar tower. She organized local women to plant trees. Simple as that. Let's plant trees.
It sounds almost too simple to work.
But it worked. They started small, just a few saplings, but the movement grew and grew. They planted millions of trees, tens of millions, and the trees did what trees do. They held the soil, they caught the rain, they restored the streams.
They brought back the natural capital.
It provided firewood, it empowered the women who were doing the work, and it healed the land. It was a perfect example of restoring the earth through simple, collective, individual action.
Sustainability begins at home. That really is the takeaway, isn't it? It's not just about what the UN does, it's about what we do.
It is the accumulation of billions of small choices. Do you take the plastic bag at the grocery store? Do you fix the broken poster? Or do you just buy a new one? Do you vote for the candidate who understands the 3 principles? Do you talk to your friends and family about this?
So let's bring it all home. We've looked at the manual. We know the 3 principles. Let's just recap them one last time.
Okay. 1, rely on the sun. It is the only truly infinite energy source we have. 2, protect biodiversity. It is our insurance policy against disaster. And 3, respect chemical cycling. Don't produce waste that nature can't handle.
And we know the financial advice. Live on the income, don't spend the capital.
Stop eating the seed corn, stop burning the floorboards to stay warm.
So we face a choice, and it comes right back to that question from the beginning. Are we smart or are we wise?
We have proven we are smart. We have the technology. We have the smarts. The question is whether we have the wisdom to look at nature not as a warehouse of stuff to plunder, but as a teacher.
A 3.5-billion-year-old teacher.
Nature has spent all that time refining a system that works. Wisdom is having the humility to say, I don't need to reinvent the wheel. I just need to stop breaking the axle.
The book quotes the architect Frank Lloyd Wright, and I think it's a really beautiful sentiment to wrap our heads around. He said, study nature, love nature, stay close to nature. It will never fail you.
It never has failed. Life persists. The only thing that might fail is us if we try to fight against those natural laws. Gravity doesn't care if you believe in it. You still fall. Sustainability is the same. It's just physics and biology. You can't negotiate with it.
So here is our final thought for you to chew on as you go about your day. We talked about the bank account analogy. I want you to look around your immediate environment today. Look at your backyard, your neighborhood park, or even just the waste bin in your kitchen. If you viewed your local environment as a bank account, did you make a deposit today? Or did you make a withdrawal?
And if you keep making withdrawals, how long until the account is empty?
Heavy questions, but important ones. The spaceship needs a crew. Thanks for taking the deep dive with us. We'll see you next time.